Hello everyone, I am Najmeh Nazari and I am glad to present our first EPC++ benchmark suite for heterogeneous architectures called HosNa. This is the outline of my talk. First, I present the overview of DPC++. After that, I introduce our benchmark and present the implementation results. Then I show how you can access and use our benchmark. DPC++ language is an extension of the C++ language for data parallel programming with complete support for SQL. SQL is an industry standard that allows using OpenCL to add data parallelism to C++ for the heterogeneous platform. There are two approaches for parallel programming. First is data parallel and second is task parallel. In the task parallel model, the user specifies the distributions of iterations among processing units, and then the data travels to the computations. In data parallel programming, the user specifies the distribution of data among processing units, and then only those units owning the data will perform the computation. The features of DPC++ supports both parallel programming styles. In DPC++, you can define which part of the code executes on which device by using queues. Usually, data is transferred by defining buffers between host and accelerators, and user can define the order of devices access to the data. Also, all kinds of parallelism can be defined, from the parallelism inside the kernel up to hierarchical data parallelism. We introduced HosNa, the first open source suite of DPC++ benchmarks for Intel platform. Our suite includes common cryptography applications, image processing kernels, as well as image rendering, machine learning, and a soft core processor. HosNa can be employed to apply several optimization techniques provided by the OneAPI toolkit to meet the hardware design constraints and achieve optimal results. We select both compute-intensive and memory-intensive benchmarks to cover a wide range of applications. Our applications have diverse sources of parallelism, such as instruction-level parallelism, ILP, and task-level parallelism, TLP. Researchers can use our suite to evaluate the features and functionality of DPC++. Moreover, our benchmark can be used as a baseline for any further analysis of optimization strategies, as we provided a simple and easy-to-use DPC++ code. Our benchmark includes different optimization techniques for DPC++ source code, such as avoiding pointer aliasing, converting nested loops to a single loops where it was possible, global memory access optimization by preloading data into local memory, having a continuous memory access whenever possible, specifying the number of memory banks and bank width, avoiding to define a float variable as much as possible. Moreover, we use pragmas and attributes for loop and memory, such as loop unrolling and max concurrency in the source code. We use Intel DevCloud to evaluate our benchmark. The processor available on DevCloud is Intel Xeon, and the FPGAs are Area 10 and Stratix 10 platform accelerated card with 20 nanometer technology. Applications are running on Ubuntu. It should be noted that Area 10 is connected to a smallest PCI Express card and is more suited for backtesting. For more compute-intensive tasks, a system equipped with a Stratix FPGA is a better solution. This slide is only an example of the implementation and evaluation of HosNa. Here we compare the performance of the accelerated applications on FPGA with the performance of applications running on CPU. And this slide shows the speed up provided by FPGA. As you can see, FPGA almost outperforms CPU by 2.8x on average. If you are curious about the more detailed information of implementation, I refer you to read the paper. The source code of HosNa is available on GitHub. You can find the link at the bottom of this slide. We are still working on it to add more benchmarks and perform more evaluation. You can find original software version of each benchmark in GitHub, which is ready to run on CPU. We provided DPC++ version of each benchmark plus the optimized version for FPGA. We also provided JavaScripts that are required to run each application on DevCloud. The sample input files and golden output files are available to evaluate the functionality of each benchmark. Also, we provide the result of performance analysis. If you want to use and evaluate HosNa, you can use Intel DevCloud. Access to is free. You just need to sign up for that. DevCloud resources can be accessed using Jupyter notebooks. So you can easily upload HosNa on DevCloud and start to explore our benchmark suite. As we said, HosNa can be used in tutorial for FPGA developers to get a hands-on Intel's platform. So for this purpose, we also developed a cloud-based FPGA curriculum in UC Davis. In this curriculum, we cover how to use DevCloud, how to migrate application to DPC++, and how to do performance analysis on FPGA and perform DPC++ optimization. This curriculum is recognized by the Intel and it's available on the FPGA academic page of Intel website. We also made this curriculum publicly available on GitHub that you can access it through this link. If you're interested in learning more, I have made a video tutorial for the curriculum under 5 labs. And the playlist is publicly available on YouTube, which is called FPGA Development on DevCloud. Thank you for your attention. I especially thank Intel for supporting and enabling this work. Now you're welcome to ask any questions.